All right, here we go. Lesson 115. Lesson 115 is talking about the remainder theorem. What I want to start off with is just doing a regular long division so that we can compare it then to long division with polynomials. So if we had the number 87 and we were dividing 7 into 87, just reminder, this is the dividend, this is the divisor, our answer is going to be the quotient. So 7 goes into 87 once, we multiply, we subtract, goes into that twice, and we have a remainder of 3. Now you know that whenever you've divided, you can take your quotient, multiply it by the divisor, and then add the remainder, and you should get your original number in here, your dividend. So if we do 12 times 7, we get 84, and then we add the remainder and we get 87, which was our original number. We can do the same thing with polynomials. So if we have what they have here, we're going to divide the polynomial x cubed plus 4x plus 2, and we're going to divide it by x plus 1. But instead of doing our long division way, we're going to use synthetic division for this. So remember, with synthetic division, we would, instead of using 1, we would use -1. And then also remember, with synthetic division, we just take the coefficients of each of the terms, but if there's a term missing, remember you have to put the 0 in for it. So here we're missing an x squared, we'll need to put a 0 in. So we're going to start with the coefficient here, which is just 1. Coefficient for the x squared would be 0, for the x would be 4, and then we have our constant of 2. Synthetic division, we just bring down this 1, and then remember we're going to multiply and add, and then multiply and add, and we'll just keep doing that. So bring down the 1, now we're going to multiply, we get -1, we add, -1, multiply, get 1, we add, we get 5, multiply, -5, we add, and we get -3. So we know that our answer for this, using the synthetic division, this was x cubed, so our first term is going to be x squared. So our answer would be x squared minus x plus 5 with a remainder of -3. Normally we would write that, the remainder is -3. We would write minus 3 over x plus 1. We're going to leave it like this for now. Remember, with the long division that we did, that we just took our answer and multiplied it by the divisor and added the remainder, and that was going to equal the original number. So that's exactly what I'm going to set up here. I'm going to rewrite this. I'm going to write it in here, actually. All right, so the original x cubed plus 4x plus 2 is going to be equal to our quotient, which was x squared minus x plus 5 times our divisor plus our remainder. Okay? So this side of the equation would be equal to that side of the equation. Now we're going to replace -1 here in the original equation. So if we replace -1 here, we would get -1 cubed is -1 plus 4 times -1 is -4 plus 2. So over here we have -5 plus 2, we get -3. Over here, if we put -1 in, -1 squared is just going to be 1 minus -1 plus 5. But what's always going to happen here is this term is going to become 0. So if we put -1 in there, well, in this case, we're using the -1. So if we put -1 in there, we have -1 plus 1, which is 0, minus 3. So 0 times any number is going to be 0. 0 minus 3 is equal to negative 3. So for this, oh, and then the way that we would write this here is we would write, for this here, we would say f of negative 1 for this here is then equal to negative 3. So which was the remainder when we use synthetic division. Now we're going to take that same polynomial and now we're going to divide it by x minus 3. So if we divide this by x minus 3, same polynomial, and now we're going to use synthetic division for this as well. This is good review for synthetic division. So, using synthetic division, instead of the negative 3, we would divide by 3, and then that just allows us to be able to add instead of subtract those numbers. Again, we're going to write these here, so that would be 1. The missing term is 0, and then 4, and then 2. Synthetic division, we bring this first term down, and we're going to multiply, and then add, multiply, and add, and multiply, and add. So we get a remainder of 41. So that means, again, the same thing, that the original, the x cubed plus 4x plus 2 is going to be equal to this here written out. Remember, this is the remainder. So this would be x squared plus 3x plus 13 times our divisor plus our remainder. Okay? So we know, let's see, if we now have f of 3 is going to be equal to some number. This is always going to come out to some number. This f of 3 is going to be 0, so it doesn't even matter what this number is because we're multiplying it by 0. So some number times 0 is just going to be 0. 0 plus 41 is 41. So we see that f of 3 is equal to 41, which was the remainder there. Now we can go on and generalize this observation by evaluating some polynomial p of x. So we'll see what this means and how we can use this. All right, so generalize this to just say p of x is equal to q of x, which is just the quotient, x minus c, that's the divisor, plus r. Now, if we replace the x with the c, so we have p of c is going to be equal to q of c, and then c minus c plus r. Again, c minus c is going to be 0, so it's going to be 0 times q of c, which is just 0. So 0 plus r is just going to be r. So we see that p of c is going to be equal to the remainder. That means that the remainder after division of a polynomial, p of x, by x minus c, is just going to be p of c. This I'm reading down at just above example 115.1. Says this provides us with an expeditious manner of evaluating polynomials, and we're going to use example 115.1 to develop this remainder theorem. Okay, so now let's look at example 115.1. It says use the polynomial equation f of x is equal to x squared plus x plus 4. And the divisor, and we're going to divide by, our divisor is x minus 3. All right, so do a specific development of the remainder theorem by showing that this is the case. In this case, that the remainder equals f of 3. So we're going to begin by dividing. So for dividing, our divisor we're going to use is 3. We don't have any missing terms, so we don't have to put any zeros in. So we have 1, 1, and 4. Use synthetic division. Bring this down. Multiply, add, multiply, add. So we have a remainder of 16. So f of 3 should be equal to 16. Well, let's try it. If we put 3 in there, we would get 9 plus 3 plus 4, and that is equal to 16. All right, so now we're going to go on to example 115.2. So as you can see, this, especially as you get into higher order polynomials, this is just a faster way to find out what the value of a function at a specific amount is. All right, so 115.2, use the remainder theorem to evaluate 2x cubed minus 8x squared minus 8x squared plus 3x plus 5. Okay, and it says use the remainder theorem to evaluate this polynomial when x equals -4. So we're actually looking at f of -4. Okay, so we're going to use synthetic division. Put the -4 here. We have a cubed, a squared, and x, so we're not missing any terms. So again, we're just going to put in the coefficients. 3 and 5. Draw our line. Bring down the 2. Multiply. And add. And multiply. And add. And multiply. So 8, 2, 6. It's going to be negative. So we get negative 263. So f of, or p, sorry, they're using p. P of -4 is equal to negative 263. Which probably faster than plugging -4 into each one of these terms and evaluating. All right. Now we're going to use the remainder theorem to do example 115.3. So this says use the remainder theorem to evaluate x to the 7th minus 4 x to the 4th plus x minus 3. When x is equal to 2. Okay, so we're going to do p of 2. All right, so again, synthetic division. We have the 2. We have 7, so we're missing 6 and 5, and 3 and 2, so we have to put the zeros in. So coefficient for x to the 7th is 1, x to the 6th is 0, x to the 5th is 0, x to the 4th is -4, x to the 3rd is 0, x squared is 0. I should have left myself a little more room. X is 1, and the constant is -3. All right. Bring down the 1, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add, oops, and multiply, add, multiply, and our remainder is 63, so we know p of 2 is equal to 63. And that's it for lesson 115.